This year's Nobel Prize in Chemistry celebrates a discovery that sounds like magic, yet stands to solve very real problems. Three scientists, Susumu Kitagawa of Kyoto University, Richard Robson of the University of Melbourne, and Omar Yaghi of the University of California, Berkeley, have been honored for the development of metal-organic frameworks, better known as MOFs. Because these materials can hold far more than their modest appearance suggests, chemists affectionately compare them to Hermione's bottomless handbag from the Harry Potter series. So what makes an MOF so special? At first glance, it looks like an ordinary powder, but zoom in and you'll find an intricate lattice riddled with nanoscale pores. That honeycomb interior gives a single gram of MOF an internal surface area roughly equal to a football field. The upshot? A pinch of the material can trap or release surprising amounts of gas, liquid, or even medicine. Building one is a bit like assembling a molecular kit. Metal ions serve as the connecting joints, while organic molecules act as the struts that link those joints together. By choosing different metals and linkers, researchers can design rigid, three-dimensional frameworks with tailor-made pore sizes and chemical personalities, a strategy the laureates call reticular chemistry. Instead of taking what nature offers, chemists can now custom-build materials for a specific task. That control opens the door to technology with global impact. Capturing carbon. MOFs can be tuned to behave like ultra-selective filters, grabbing carbon dioxide from smokestacks or even directly from the air. Locking away CO2 before it reaches the atmosphere could slow the pace of climate change. Storing clean fuel. Hydrogen is an appealing zero-emission fuel, but its low density makes safe, lightweight storage difficult. The cavernous interior of certain MOFs can pack large amounts of hydrogen at low pressure, bringing hydrogen-powered cars and trucks a step closer to everyday use. Harvesting water from desert air. Some frameworks act like microscopic dehumidifiers, pulling water molecules out of even arid air and releasing drinkable water when warmed by sunlight. For communities facing chronic drought, that could be transformative. Purifying the environment. Other MOFs trap toxic gases, remove forever chemicals from drinking water, or scrub industrial exhaust, offering a versatile toolkit for pollution control. Delivering medicine. In the lab, researchers are loading drug molecules into MOF pores so that treatments can be ferried through the body and released exactly where they're needed. The field has exploded since Kitagawa, Robson, and Yaghi laid its foundations. Chemists have now reported tens of thousands of distinct frameworks, and the combinations of metals and linkers still left to explore seem almost limitless. By honoring MOFs, the Nobel Committee underscores a simple truth. Breakthroughs in fundamental science can ripple outward, reshaping industries and addressing urgent global challenges. From cleaner energy to safer water, these Hermione's handbag materials may soon prove that, with smart chemistry, there's always room for one more solution.